All right. Good evening, students. I welcome you for another lecture on transition elements. We have already discussed the halides, oxides, electrode potential values, standard electrode potentials of transition element students. And we have answered many important questions, like the questions which are on the screen, students. Just to give a small recap of what we have been doing. Question answer session is always important. Important questions should be discussed with students repeatedly because they will be asked and can be repeated for the exam. So student, what we have been telling you in the transition elements students, various important properties, atomic properties like ionic radii, ionization enthalpies, trends in atomicity, and also we have discussed the oxidation states exhibited by various transition elements. And for example, if the first question here is in the series of scandium to zinc, enthalpy of atomization of zinc is the lowest. What was the answer for that, students? For each
In the
question, you have 30 seconds only. 30 seconds. You already know the
scandium
answers.
to zinc enthalpy of atomization of zinc is the lowest, that is now why. So because zinc has D10 configuration, fully
Yes.
filled d orbital.
All right, so you have D10 configuration. That means what something more than that, that there are no unpaired electrons.
No unpaired
Here the
electrons.
question
Yeah.
was based on unpaired electron. Students, see question answers when we do, we know what words to be used at what point. The enthalpy of atomization is very much dependent on the number of unpaired electron. With increase in number of unpaired electron, it increased because the metallic bonding increases. That was the idea. Name the transition element which do not exhibit variable oxidation state.
It is scandium.
Scandium only has +3. Number 3, why Cr2 plus is reducing and Mn3 is oxidizing when both have D4 configuration.
Sirs, chromium 2 plus is reducing because
Chromium,
its
ah,
its configuration changes from D4 to D3, and Mn3 plus is it has half filled T2G orbital.
you have given a wrong answer now. That was a problem. I knew that. Why do I revise the things? The whole answer has been reversed.
Okay, so just 2 minutes. Let me just write the
I will
configuration.
tell you how do you answer the questions in the exam. That's why we are giving a revision of the question answer session repeatedly to you, because we know where you are doing mistakes in the exam. Students, if you will answer without thinking, your answer is wrong.
Yes, sir. So chromium 2 plus is reducing because it changes from D4 to D3. D3 configuration has a half filled T2G level
That was the
from
point was this is T2G3 half filled.
T2G3. Yes, a half filled.
That
And
has
Mn3
to be
plus to
written.
Mn3 plus to Mn2 plus is half filled configuration, which has extra stability. D5 configuration.
What we are saying, Mn2 plus is D5 half filled. This is how you write in the exam, student. If you write anything else, not acceptable. Not acceptable. So be careful. That was the question reason we have been asking you to do the question answer. We will be doing mistakes today. You know the answer. You still not write the correct answer. So marks will not be given. Next, it's not that you don't know, but what you are writing is will be counted. Students, next question before you. E naught M3 M2 to M value of copper is positive. What is the possible reason for this? You already know it. 30 seconds only.
Yes, sir, because delta H sublimation and delta H I, they are compensated by a very high hydration enthalpy
Okay,
for
that
copper.
is a correct answer. Or in other words, I am saying delta hydration H, ठीक है, compensates delta atomization plus delta ionization. ठीक है? Okay. Next question. How would you account for the increasing oxidizing power in the series? In the series, student.
Chromium MnO4. Okay.
What is the oxidizing power? Okay, you have 30 seconds to answer the question. And you have to think before you answer. Don't give any answer without any thinking.
Sir, this is because uh, the species in which they are reduced, the lower species in which they are reduced, they are very stable.
Very stable.
Lower species in which they
That
are
is the
reduced.
answer, or something more is there? Did you find the oxidation states of each element? What is the oxidation state of vanadium in VO2? Find the oxidation number of vanadium. Find the oxidation number of Cr2O7. Find the oxidation number of manganese. Manganese, find it fast. What is the oxidation number of?
It will be
If I take it X,
it is +5.
X minus 4 is equal to +1. The vanadium is in +5. What is
5.
chromium?
Chromium is 2x minus 14 is equal to -2. 2x minus 2 plus 14 +6.
Okay, +6. Chromium, you are saying, is students +6. And what is the oxidation state of manganese?
It will be -1. It is MnO4. Okay, MnO4.
MnO4 or
4. MnO4.
Okay, MnO4. Oh,
Yes. X minus 8 is equal to -1. -1 plus 8. +7.
now the answer is there. The higher the oxidation state, the more oxidizing, what will happen? It has to be reduced. Higher the oxidation state, more it is going to be reduced. Stronger is going to be the Lewis acid, student. Here the answer lies in the oxidation number. Oxidation number. Can you see it?
Okay.
What was the reason I took these question answers? It's not that the answers are not known to you. What you are writing is an important point in the exam. What we are writing further. Next question on the screen. How would you count for the irregular variation of ionization enthalpies? First, second in the. We have answered this question earlier also. Ionization enthalpies depends on what factor, students?
Sir, they have different, they have irregular variation of ionization enthalpy because they have variation in the degree of stability of different 3D configuration.
And something more, you have found some irregularity in their atomic sizes also.
Atomic sizes also.
It's a combination of the factors, not one factor. Did you find that how the atomic radius were changing? They were decreasing, then became constant, no, almost equal. And then there was small increase also by the end of the series. Did we see that in the graph?
Yes, sir.
So there was no, when the trend is not regular in the atomic radius, and in case of extra stability of electronic configuration will also be important. Okay, and once you remove one electron, then second ionization enthalpy we are talking about. Then what will happen? The d and s orbitals are quite close in energy, and there is a exchange of electrons from one to other. Reorganization of the orbitals can take place. Further, next question. Why is the highest oxygen metal exhibited its oxide or fluoride only?
Sir, this is because the oxide and fluoride, oxygen and fluorine have very small size and high electronegativity, so they can oxidize the metal in to its
Strongest
highest
oxidizing
oxidation
agents,
state.
most electronegative element. We always talk of If I talk of fluorine or oxygen, they are the strong oxidizing agent. Fluorine is the strongest oxidizing agent that we know and most electronegative element. Okay, next question. Which is stronger reducing agent, Cr2 plus or Fe2 plus? And why, students? Why?
Okay.
So many questions coming in a different
Uh,
form. Students, series very important questions have been placed before you on the screen. Very, very important questions. They are for the exams. Reducing agent is means what? When I say it is a reducing agent, you are saying it is going from 2 plus to 3 plus. It is
3
undergoing
plus.
oxidation. Iron is
So
undergoing oxidation.
it will be for chromium, the change would be from D4 to D3, and for uh, the D2, D3 to zero. हाँ तो D3, yes, so D3 has this T2G which is more stable. हाँ.
What is the atomic number of iron?
Iron is 26.
Iron is 26. That means what is the configuration, student? 4s2 3d
3D6.
3d6. 4s2 3d6. 4s2 3d6. Then what will happen? Scandium, titanium, chromium, manganese, iron. Iron 2 plus is 3d6.
Iron 3 plus by 3D5. 3D6 to 3D5.
3d5. That is also a stable configuration. That is also a stable configuration. What is the value of the electrode potential value of iron 2 to iron 3? We had some value somewhere. Where is that value? Iron 3 to iron 2 plus. So iron 3 to iron 2 plus is 0.77. And what is chromium? 3 to 2 plus. Minus. So which will go 3 to 2 plus minus and 2 to 3 plus 2 to 3 plus will become minus 0.77. 2 to 3 plus minus 77. This will become plus 4. What we are talking? Which agent? Reducing agent means
Reducing
oxidation.
agent.
So this chromium is stronger. Chromium is stronger. The only answer I can give is this one.
Okay.
We have to be careful of what answers we are giving students because we have to think and study everything. Most of the times we are finding the reasons for the experimental facts which we observe students, which we observe.
Okay.
And reasons have to be given as per certain concepts of chemistry which we are learning. Now we are coming to another important property of the transition elements. Transition elements, students, show magnetic properties. Transition elements, students, exhibit magnetic property, and questions are asked on this. What do you mean by magnetic property, students? You have already known, you know about it in physics, also in chemistry, also. What type of substances we are talking of? There are certain substances, students, which are attracted, by the magnetic field.
Yes, sir.
They are attracted towards the magnetic field.
Magnetic field.
What do you call them as? Substances are those which are attracted by the magnetic field, student. If you apply a
These
field, they are
are
attracted. They are called paramagnetic
paramagnetic substances.
paramagnetic substance. Okay, this is the first thing. Certain substances are very strongly attracted by the magnetic
Paramagnetic.
field. What are they called?
Ferromagnetic.
We will study them later on also about them. Paramagnetism, paramagnetic. And there are other students which are repelled by the magnetic field. What are they?
Diamagnetic.
Repelled, diamagnetic, diamagnetic. So what we see that larger number of transition metal ions. Transition metal ions, student, exhibit paramagnetism. Paramagnetism. What it means? They will be attracted. They will be attracted by the magnetic field. What is happening, student? Actually, electron has two types of, movements. Electron is orbiting around the nucleus. Also, electron has a spin moment. There are two types of movements which are associated with the electron. One, you have the electrons. What they are doing, student? They have orbital angular movement. And what is the second one? Spin angular movement. So electron are having orbital angular momentum as well as a spin angular momentum. What happens in our case in the transition elements, student, in the D series, in the 3D series, for example, in the 3D series or in the transition elements in the D series, what we are saying, students, the electrons are which are present in the outermost valence are responsible for this magnetic property, are responsible for the magnetic property, whether they will be diamagnetic or paramagnetic. And this orbital angular momentum is not important for them. What I'm saying, this orbital angular momentum contribution negligibly small. Contribution of orbital angular momentum, student. So thus orbital orbital angular momentum contribution is not effective, is quenched, therefore is of no significance in the case of the transition elements. So we will be only considering the spin only movement, spin only magnetic movement, student, for these transition elements, So the magnetic moment will be
Okay.
determined by, if there is a, this will be based on unpaired electrons.
Okay.
If the transition element has got unpaired electrons, then it has a spin magnetic moment. Then it will have spin magnetic moment, student. The spin magnetic moment is due to presence of unpaired electrons. If the electron is paired, then the cancels out. The spins are cancelling out, and only when there is an unpaired electron, it has a spin magnetic moment. So it will depend on the number of unpaired electrons. This will depend on number of
Unpaired electrons.
unpaired electrons, student. Number of unpaired electrons. And you know, a formula has been given in order to find the spin. That formula we have given here. The magnetic moment can be calculated, student, by a formula n plus 2. So magnetic moment is determined by the number of unpaired electrons, where n is the number of unpaired electrons in the metal ion. So if I put the value of n, I will be able to get the value of mu, which is expressed in Bohr magneton, Bm. The unit of this is Bm. This is called Bohr magneton. And Bm they write, which is Bohr magneton. The unit is, students, Bohr magneton. This is called Bm. Bm is Bohr magneton, students. In physics, you will study more about it. And basically,
Okay.
one Vm is a very small value, which is given by a formula in physics, Ah by 4 pi mc, where m is the mass of the electron, c is the velocity of the light, E is the electronic charge, h is the Planck's constant, and the value of this comes
Yes,
to
sir.
be 9.27 into 10 power minus 24 a meter square. So you can see that it's a very small value, 1 bm. It's very small. The one electron value, how much it will be, we can put the values and see in Bohr magneton. In Bohr magneton, if n is equal to 1, supposing, then what is the value coming, student? Mu is equal to 1, 2 plus 1, 3,
1 3
root 3.
root 3.
What is that? We know the value of root 3,
1.732.
1.732. Bohr magneton. Bohr magneton.
Okay.
Therefore, we can calculate the magnetic properties by knowing the number of unpaired electrons. Now the questions are going to be there, students. Questions are going to be there.
Okay.
For example, now supposing I said ki find the magnetic moment, find the magnetic moment for Ti3 plus. Find the magnetic
TI3
moment for
plus. Okay.
Ti3 plus. Okay, let me go back because this.
TI plus will be, this will go, it will have one unpaired electron. It will have 1.732 Bohr magneton.
Okay, we are going to take some examples because a question is likely to be asked to student in the paper. This has been asked many times. We are taking it. Once the students who know it, they will easily get a mark here. Okay. Now we have a question. Question number 2. Calculate the magnetic moment. Calculate the magnetic moment of a divalent ion in aqueous solution if its atomic number is 25. This question. Question number 2. Calculate the magnetic moment of a divalent ion in aqueous solution. Atomic number is 25. Students, atomic number is 25.
Okay. It will be 5.92 Bohr magneton.
Atomic number is 25. Then what is the electronic configuration, students?
It is 4s2 3d5.
So atomic number is 25. Okay. This is a 3d5 4s2. Okay. And m2 plus means 3d5. Okay.
Yes, sir.
And that means number of unpaired electrons, students.
It will be 5.
Number of unpaired electrons is 5. N is equal to 5. Then what is the formula? Mu is equal to n into n plus
Plus
2.
2 under root. So
5
5 into 5 plus 2. 5 into 7 under root 35.
under root 35. So this will be slightly less than 6.
5.92.
5.92. All right. So we can calculate. We have to write the units have to be mentioned. Okay. Question 3 on the screen. Calculate the spin only magnetic moment M2 aqueous Z is equal to 27.
Twenty-seven. It would be 3.87.
3.87. Z 27. What is the configuration M2?
4s2 3d7. Then M2 2 gone 3d7.
M2 is 3d7.
3d7. Then it will have 3 unpaired electrons.
So we have to be careful now. How many unpaired? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7.
7. 3 unpaired
N
electrons.
is equal to 3,
3.
mu is equal to square root
3
of n
into 5.
plus 10. 3, 3 plus 2, how much is that? Square
3
root
into
of
5.
20. नहीं 3 plus
15 under root 15.
under root 15.
3.87.
3.85 more magnetron. There was a question. Question was find the spin only magnetic moment Ni2 plus.
Nickel 2 plus. Okay. It's 3D8. 3D8 will be it will be 2.828.
2.828. How many unpaired electrons are there, students?
2 unpaired electrons.
Two unpaired electrons. Two unpaired electrons are there. So, two unpaired electrons.
828.
Okay. 2.828. What is the atomic number of nickel?
Nickel is 4s2 3d8.
28.
Yes, sir.
Because this first series we have to learn because they will not give you the atomic
Yes,
number.
sir. Yes, sir.
Scandium to zinc we should learn. So 3d8 and 4s2. Then nickel 2 plus is
2 gone,
3d8.
4s2 gone, 3d8.
So how many?
2 unpaired electrons.
3, 3, 4. 2, 3, 4, 5, 6, 7, 8. 2 unpaired electrons. And therefore, how much we are getting, students?
2 into 2 plus 2, 4.
Square root of 8.
8. 2.828.
2.8. Supposing, okay, something like that. So now the one more trend is coming for us. What is it? If we will find the magnetic moment values, if we will find the magnetic moment values, some trend is visible to us, some trend is visible. What trend is visible? Okay, for us in the exam, we are quite comfortable. We can get some information because sometimes objective type questions are given. The exam 4 marks questions. What we are saying, if we observe everything carefully, pay attention, a lot of things will come. If we are fast, then we will miss a lot of things. Our memory also depends on how well we learn the things. Memory becomes stronger when we start learning the things, students, and spend some extra time on something. That is the point, student. Well, we are learning student. If I say that in general, what I'm saying, number of unpaired electrons. This we can calculate. And what we are getting, magnetic moment. Basically spin only for it works. Bohr magnetron. Okay. In general, if you have 0 unpaired electron, this is 0. If you have 1 unpaired electron, it's coming to be around student 1.74. 2 unpaired electrons, if you are getting, it is coming to around 2.83, something like that. If there are 3 unpaired electron students, then it is coming to around 3.86. 4, it is coming to around 4.80.
So these values have to be learned.
No, nobody's asking you to learn. I'm just giving you trend. 5 unpaired electrons.
Okay.
5 unpaired electrons, 5.92. If can there be 6 unpaired electrons?
No.
Okay. I'm talking of M2 plus. That's all. One thing, if the Bohr magneton is, if unpaired electron is 5, then it is 5.92. Or if Bohr magneton is given to me, supposing they say 4.8 is the Bohr magneton, find the number of unpaired electrons. Number of unpaired electrons. I don't have to apply the formula. I can apply, nobody stops you. Question. But I can straight away say n equal to 4. This number. And you want to calculate, you can apply the formula, which is that this formula you can apply, no problem. But faster approach is I'll just take the first value.
Okay.
I mean, it's clear from this. That's why I have given these values. That data is just we are trying to analyze the data. Students, if the value is 5.92, it is showing that this 5 is the unpaired electrons. This well, number of unpaired 5. 4.8, 4, 3 point something, 3, like this. So we are now able to get ideas about them. Okay.
Okay, sir.
All right. The second important property for the transition elements, students, where question will be coming, formation of colored ions. What we're talking, formation of colored ions, students. Now we are saying transition elements form colored ions.
Okay.
Formation of colored ions. If you go to the chemistry lab, probably once you see the compounds, whenever you see the compounds of the transition elements, what you find, student, what you find that they are colorful compounds. Probably if you will go potassium permanganate, if you see the colors of these KMNO4, K2Cr2O7, you can see copper sulfate and nickel cobalt compounds. What do you find, students? You are seeing beautiful colors, beautiful colors. You are seeing beautiful color, students, of these compound. What do you find? MnCl2, or if you will find uh, copper sulfate, CuCl2, Fe,
Okay.
Fe compounds, FeCl2 or FeSO. What do you find? You are finding colors,
They are colored.
highly colored ions are there in the transition elements. Why they are forming colored compounds, student? Why colors? This is one of the important property which we told you for the transition elements, that they form colored compounds, colored ions. What is the meaning of color, student? Why the color is coming? Why the color is coming? Color will always be if light is absorbed in the visible region. There is a absorption of light in the
Okay.
visible region, student. There has to be absorption of light. In the visible region. So if the light is absorbed in the visible region, student, what will happen? When visible light is absorbed, what will happen, student? Then you will see a complementary color of that. But why will light be absorbed? That is the question. Light will be absorbed
Okay.
only if there is an excitation of electron. Now, how the excitation of electron will take place in the transition element? That is the question, student. That is the question. What happens in the transition elements? You are aware of that when there are 5d orbitals. You are aware there are 5d. How many d orbitals are there? 5d orbitals. And you
5.
have seen the shapes of them also in the book. Now, when the ligands approach these transition
Yes, sir.
d orbital, when the ligands approach the d orbital, student, what happens is splitting of d orbitals take place. Splitting of d orbitals will take place, students.
Sir, what are these ligands?
We will tell you, we are going to study the coordination compounds next time. Or whenever you see certain, these are ions in the solution. Whenever you have ions in the solution, what is the meaning of that? There are even water molecules surrounding them.
Okay,
So
okay.
there are those ligands are those groups which can donate electron pairs because transition elements have vacant d orbitals. They can accept electron pairs. They are Lewis acids, so they can accept electron pairs. So when what will happen is when the ligands or other molecules are approaching, even water molecules are approaching, student, what will happen if water molecules can act as ligands? Water molecules can act as ligands. We'll explain to you more about this in coordination chemistry. This is our water. It has lone pair of electrons. This is a Lewis base. Transition elements have vacant d orbitals where they can accept the lone pairs of electrons. When they approach the d orbitals, the splitting of d orbital take place because the symmetry of d orbital is destroyed. 5d orbitals, which we are saying, these are the 5d orbitals. Students, they split up into what we have been talking, something like T2G and EG.
G,
Or there is
EG.
another way of splitting also, but splitting takes place. This D
Okay,
generate d orbital. These are the 5d orbital, students. They are splitting up into set of 1, 2, 3. This is a octahedral complex when it is formed. Now this is, you can see there is a energy gap between this T2G to EG. This is called DD transition. What do you call this as a DD transition, students? The electrons can be excited from here to EG. That
okay,
energy falls in the visible region. That energy falls in the visible region. So when they will absorb light in the visible region, electrons will be excited from T2G to EG, student. This is what we call as a DD transition takes place. Due to the DD transition, students, they become colored. So the colored, whatever colored solution you are seeing is because of this excitation of electron by when they absorb light in the visible region. So the color absorbed corresponds to complementary color of the light absorbed. So what you will observe, student? Complementary color. Complementary color to light absorbed. And the condition is very clear now. Condition, what is the condition to absorb the color? They must have at least one or more unpaired electrons. Then only excitation will take place, one or more unpaired electrons. If they don't have one or more unpaired electrons, then there will be no color. There will be no color, students. So this is an important point which I have told you. How will we say that this will be colored or this will be colorless? How will we prove this will be colored or this will be colorless, student? This is important point. If you noted down this, I will give some questions on this now because this is an important point. There will be questions based on colors of the transition elements, student. Color of the transition. They form colored compounds.
okay.
Can I rub this?
Yes, sir.
Okay. Another way of saying is always that when electrons are undergoing DD transition from TTG to EG, students, so they will be excited, but the excited electrons, when they return back to the lower states, they will emit lights, which we see as colors. Now, for example, question. He says ZnSO4 is colorless. But copper sulfate is blue in color. Explain, student. You have 1 minute to answer the question, students.
-4 is colorless, so CO2 is color.
What is Zn2 plus? And you have copper 2 plus aqueous. What is the configuration of Zn2 plus?
D10.
What is the configuration of copper 2 plus?
Copper 2 plus is 3D9.
89. So there are no unpaired electrons.
There are no unpaired electrons in Zn. Okay.
Here you have unpaired electrons. You have unpaired electrons.
Okay.
Unpaired electrons, we have told you very clearly one very simple thing, one very simple thing to answer lot of questions, student. And now we are saying scandium 3 plus compounds colorless, but Ti3 plus purple in color. You have 1 minute. Purple in
Scandium 3 plus and titanium 3 plus. Scandium 3 plus and colorless and Ti3 plus. Scandium 3 plus has no unpaired electrons, 4s0, 3d0, and titanium 3 plus has one unpaired electron.
Scandium 3 plus is what? 3d0.
3d0.
Oh, no, he doesn't have any electron. No electron in d orbital.
No electron.
In d orbital. So what excitation is possible? Nothing. There is no electron. No electron in d orbital. And what is titanium 3 plus?
It has one unpaired electron.
What is the configuration? 3d1.
3d1.
It has one unpaired electron. In other words, if I have to show it, student, what I'm trying to tell you again, just to show you, I don't need to show it in the exam unless question is based on that. There is a one electron here, T2G, EG. In the case of titanium 3 plus.
Titanium 3 plus.
And that energy will be absorbed, this will be excited. This electron will go from T2G to EG. T2G to, it will become T2G0, EG1, excitation. Got it?
Yes, sir.
And when it will absorb light, then it shows color. It shows color. So the color can be explained, student, on the basis of the absorption of light in the visible region due to the DD transition. Very, very important. What we call as, this is called DD transition. Answer to be written DD transition, which means T2G2
EG.
because the d orbitals have already split up. So you can see wherever such things are possible, student, and we have generalized, I mean, form a conclusion ourselves after doing so many questions. that
Okay.
if unpaired electron will be there, then such a process will be possible. Otherwise, not possible. Otherwise, it is not going to happen, students. So if I say that chromium 2 plus, will it be colored or colorless? Chromium 2 plus will be colorless
Chromium 2 plus.
or colorless or colored.
Chromium 2 plus will be चला जाएगा यहाँ से और एक और यहाँ से चला गया 3D4. It will have color.
So because there are unpaired electrons
Unpaired electrons.
in chromium 2 plus.
2
In
plus.
chromium 2 plus. So questions can be put in many ways. What he said that Ti4 plus is colorless, but Ti3 plus Ti3 plus is purple. Explain, students.
Ti4 plus and Ti3 plus. Okay.
Explain.
Ti4 plus and okay. Ti4 plus, in Ti4 plus there are no unpaired electrons, 3D0, no electron in d orbital, and in Ti3 plus there is one unpaired electron.
Okay. So here is the story about the colors of the transition elements. Students, we have told you the important properties of the transition elements, which will be there. Question could be there in the exam. Usually it is asked from this part. And we have shown you how to calculate the magnetic spin, only magnetic moments for the transition elements. And we have tried to generalize certain rules on both the cases. And I don't go into more details. Once I have learned it to see unpaired electrons was present or not, then I decide, hey, if unpaired electron present, magnetic moment will be there. Yes or no?
Yes, sir.
If unpaired electrons are present, color will be there in the metal ions in solution. Yes or no?
Yes, sir.
So our conclusion is very simple. So, okay, then this lecture ends here. We will continue with more important properties of the transition elements in our next lecture. There are plenty of questions which have been discussed and they have been asked repeatedly in the exam, students. Okay, then good night. We'll meet you in the next class. Okay?
Okay,
I hope
sir.
you have noted down everything, students.
Yes, sir.
Okay, then good night.
Okay, thank you, sir.